Today we will discuss NMR. First question, what is NMR? NMR is nuclear magnetic resonance. When we apply magnetic field to atom, the nucleus of atom will either align parallel or align opposite. So the second point, if you are seeing the first point, question is what is NMR? First point is NMR is full form is nuclear magnetic resonance. It is a resonance of nucleus in the magnetic field. That is its meaning. So second point is telling when we apply magnetic field to atoms, then the nucleus of the atoms will either align parallel or align opposite. Why it is like that? Because atoms has nucleus. Nucleus has proton. Proton is in the nucleus will spin along its own axis. If a charged species is spinning along its own axis, then it will act as a magnet. So if you are thinking about a magnet, if you are keeping a magnet inside another magnet, then it will try to align. Then it will try to align according to this magnetic field. So if you are thinking of north to south, if we are arranging, here it will be south, here it will be north. So the second point is telling when we apply magnetic field to atoms, then the nucleus of atoms will either align parallel to or align opposite to the external magnetic field. Opposite to the external magnetic field. Okay, so 90% of the nucleus will try to align parallel to the external magnetic field, but 10% of the nucleus will align perpendicular to the opposite to the external magnetic field. So the second point is when we apply magnetic field to atoms, then nucleus of atom will either align parallel or align opposite to the external magnetic field. So we will get two states. Means this will result two spin state called alpha and beta. So alpha spin state is aligned parallel to the external magnetic field. Beta spin state align opposite to the external magnetic field. So if initially the spin is like this, there is no energy. So initially there is no splitting of the atomic nucleus. So what we are doing, we are not giving any magnetic field and there is no splitting of the nucleus in the atoms. Then we are slowly increasing the magnetic field. If we are increasing the magnetic field, some of the nucleus will try to align and parallel along with the magnetic field. Some of the nucleus will try to align opposite to the magnetic field. Who are trying to align the magnetic field will be having less energy, and if we are trying opposite to the magnetic field, we have higher energy, beta. So if you are thinking that alpha and beta energy difference will increase if you are increasing the magnetic field. Magnetic field unit is generally Tesla. So what is the point is telling? This will result to spin state which is called alpha and beta. Alpha has lower energy spin and beta has higher energy spins. Resonance between the nuclear spin state is called nuclear magnetic resonance. Resonance माना क्या है? We have studied benzene. Benzene has a resonance structure. Resonance structure means क्या है? Electrons are rotating around this. Means it is not constant. It is rotating around it. So resonance means somewhat which is not constant and which is resonating, which is vibrate or which is moving from one point to another, again that point to original point. That is called resonance. Okay, so what is the point is telling? Resonance. So question is nuclear magnetic resonance. We have to define why it is resonance, we have to define why it is magnetic, we have to define why it is nuclear. So these first two terms we have already defined. Magnetism is due to we are applying external magnetic field. Nucleus is due to because nuclear spin state we are studying. Now we are telling about resonance. What is the point? Point is resonance between nuclear spin state is called nuclear magnetic resonance. So we got a spin state alpha and beta, and that spin state energy is increasing along with the energy difference is increasing along with the magnetic field strength. So if you are thinking in that way, alpha and beta energy difference will increase if we are increasing magnetic field. But resonance will happen only when we apply radio frequency. When we apply radio frequency, some of the nucleus is there in the alpha spin state. Some of the nucleus will be there in the beta spin state. Originally very less amount, almost 10% or almost 1% of the nucleus will be in the beta spin state. But 90% or 99% of the nucleus will be in the alpha spin state. But when we give radio frequency, what will happen? This will resonate. Resonate means this will nucleus which have lower spin state will go to higher spin state. Nucleus will have higher spin state will go to lower spin state. So that is called radio. So radio frequency, if it is absorbing, means nucleus will go to lower spin state to higher spin state. But if radio frequency is emitting, means it will go from higher spin state to lower spin state, or we can tell simply beta to alpha. So that resonance is called nuclear magnetic resonance. The point is, resonance between nuclear spin state is called nuclear magnetic resonance. For resonating between two spin states, we have to apply radio waves. The condition is that resonating between two spin states, we have to apply radio waves. So we will one more time conclude what is NMR. Nuclear magnetic resonance is called NMR. When we apply magnetic field to atoms, the nucleus of atoms will either align parallel or align opposite to the external magnetic field. This will result two spin state, which is called alpha and beta. Resonance between nuclear spin state is called nuclear magnetic resonance. For resonating between two spin state, we have to apply radio waves. So this is a detailed answer, but if in exam if you are asking what is NMR, the full form is nuclear magnetic resonance is called NMR. Next question. What is criteria for a nucleus to be NMR active? Yes, according to the question, we can understand that all nucleuses are not NMR active. Some nucleus are NMR active, some nucleus are not NMR active. So what is the condition? Which are the nucleus is NMR active? Which are the nucleus is not NMR active? So condition is atom which have atomic number or mass number or both. What is the condition? Atoms which have atomic number. Atomic number means it will be denoted in down. Number of protons is atomic number. Atoms which has atomic number or mass number. Mass number means number of proton plus number of neutrons. Or both. So in the case atomic number and mass number both are same, and that is odd. In this case also atomic number and mass number are odd. In this case atomic number and mass number are even. So condition is three conditions. Atomic number can be odd, mass number can be odd, or both can be odd, not even. Odd. So remember, I have removed this even, I have written odd. For NMR active condition is odd. Atoms which have atomic number or mass number or both has odd integer are NMR active. For example, here atomic number is not odd, it is even. Mass number, it is not odd, it is even. This is not NMR active. Okay. Here if you are seeing, I will tell what is odd means 1, 3, 5, 7. These are odd. Even means 2, 4, 6, 8. These are even. So if you are seeing these are even, so this is not NMR active. So if you are thinking about second nucleus, carbon 613. So this is odd number, this is even number, so this is NMR active. Here both are odd number, no doubt this is NMR active. This is even number, but this is odd number, this is NMR active. This is even odd number, this is also odd number, this is NMR active. So which are the nucleus is NMR active? either mass number or atomic number or both has to be odd, then it will be NMR active. What is meant by 60 MHz NMR machine and 400 MHz NMR machine? So what is its meaning? What is meant by 60 MHz or 400 MHz NMR machine? Megahertz means megahertz is the unit for radio frequency. Radio frequencies, the unit is megahertz. Megahertz means 10 raised to 6 hertz. Okay, in an NMR machine, second point, in an NMR machine, external magnetic field and applied radio frequency are important. In NMR machine, what are the things important? We have seen previous class, previous page. There is magnetic field is important and radio frequency is important. Why magnetic field important? Because magnetic field is the reason for the splitting between two spin state. Radio frequency is important. Why radio frequency is important? Because radio frequency is the reason between the resonance between these two spin state. Okay, so what is meant by 60 MHz machine and what is meant by 400 MHz machine? So second point is, in NMR machine, two things are important: external magnetic field and applied radio frequency. If external magnetic field of an NMR machine is so powerful, external magnetic field of an NMR machine means it will cause splitting of two spin state. If that is so powerful, means that splitting energy difference will be huge. That we have seen. Magnetic field is increasing means external magnetic field is more powerful, means that spin state will be more. The energy difference between the spin state will be, first it is here, then it is here. Energy difference between the spin state will increase. That's what is written. If external magnetic field of an NMR machine is so powerful, then spin state of nucleus will be splitted. It will be splitted and splitted spin state energy will increase. Okay, so second, then the next point. Energy difference between the splitted spin state can increase by increasing the strength of the magnetic field. That we have seen. By increasing the strength of the magnetic field, the energy difference between the spin state can increase. Next, when the energy difference between the splitted spin state is equal to applied radio frequency, then only nucleus will excite from lower alpha spin state to higher beta spin state. When the resonance will happen only when the radio frequency energy and the energy difference between the two spin states are same. Then only radio frequency nucleus will absorb the radio frequency and will go to from lower to higher. So the condition one more time I will read. When the energy difference between splitted spin state is equal to applied radio frequency, and the difference between splitted spin state and that is equal to applied radio frequency, then only nucleus will excite lower alpha spin state to higher beta spin state. So now we will understood the background. Okay, alpha spin state to beta spin state excite करने के लिए, if you want to excite there, then radio frequency is needed. So applied radio frequency will absorb by the nucleus and it will excite from lower spin state to higher spin state. Now if you see, the question is, what is the question? Question is, what is the meaning of 60 MHz NMR machine and 400 MHz NMR machine? So the answer is, in 60 MHz NMR machine, applied radio frequency is 60 into 10 raised to 6 Hertz. Yes, nothing I have done. I have taken this unit and I have elaborated it 60 into 10 raised to 6 Hertz. This is the applied radio frequency. In 60 MHz NMR machine, applied radio frequency is 60 into 10 raised to 6 Hertz. What is its meaning? Which means the strength of the magnetic field produced, strength of the magnetic field, the power of the magnetic field produce, the power of the magnetic field, of course it can produce split in the spin state, right? That's what we have told. The power of the magnetic field produce split of the, first it is not splitted, then due to power of the magnetic field it is splitted, then the split energy is increasing. So that thing, the same thing only has written here. What has written? Which means the strength of the magnetic field produced the strength of the magnetic field produced a splitted energy state. The splitted energy state has the energy difference 60 megahertz. Yes. If the energy of the radio frequency is equal to its energy difference, then only the nucleus will absorb this radio frequency and will go from this energy to this spin state, to this spin state. So the 60 megahertz NMR machine means we are applying a magnetic field such a way that this energy difference will be 60 megahertz. So that 60 megahertz is the unit for frequency, and we know the relation between frequency. What is the relation between E energy is directly proportional to frequency. If that is like that, means then 60 megahertz NMR machine will produce a spin state, two spin state with the energy difference 60 megahertz. Okay, so the point one more I will tell. In 60 megahertz NMR machine, applied radio frequency is 60 into 10 raised to 6 hertz, which means the strength of the magnetic field produced a splitted energy state with energy difference of 60 megahertz. Okay. So next point, then what it will be 400 megahertz. Similar way we can write in 400 megahertz, the applied radio frequency is 400 into 10 raised to 6 hertz, which means the strength of the magnetic field, produced a splitted spin state with the energy difference of 400 megahertz. Splitted spin state, the energy difference will be 400 megahertz. So the conclusion is, question was one more time I will repeat, what is meant by 60 megahertz NMR machine and 400 megahertz NMR machine? So answer we have written, and the conclusion is the strength of the magnetic field, energy difference between the splitted spin state are larger in 400 megahertz compared to 60 megahertz. The energy difference between the spin state and strength of the magnetic field is larger in the case of 400 megahertz than 60 megahertz. If somebody asking 400 megahertz and 600 megahertz means in which case energy difference will be large? The energy difference between splitted spin state will be large. Of course, 600 megahertz energy difference will be large. First 600 megahertz, then 400 megahertz, then 60 megahertz. It will be like that. Next question. What is the relation between radio frequency absorbed by a nucleus in magnetic field and electron density around the nucleus? Question is, what is the relation? If there is a relation, please tell the relation. What is the relation between radio frequency absorbed? Radio frequency, when it will absorb, we know the splitted spin state is forming, then only radio frequency will absorb alpha spin state and beta spin state, that this is called splitted spin state. If this spin state is forming, then only radio frequency will absorb. The question is, what is the relation between radio frequency absorbed by the nucleus in a magnetic field? So splitted spin state has to happen, means magnetic field should be there. That's why in question itself there is written, what is the relation between radio frequency absorbed by a nucleus in magnetic field and electron density around the nucleus? Okay, there is a relation. How much radio frequency a nucleus can absorb and electron density around the nucleus. Okay. So we will explain what is this. We know this is an hydrogen atom example. There is a proton inside the nucleus. Proton will rotate around it. If it is rotating along its own axis, then it have a magnetic momentum. If that has a magnetic momentum, we can consider it as a magnet. If you are thinking about electron is rotating around the nucleus, but it is also rotating around its own axis. Since it is rotating around its own, it also has a magnetic moment. What is happening means this magnetic moment is embedded inside this magnetic moment. Electronic cloud is almost everywhere. So what is happening is this magnetic moment of electron will act as a shield, means I will hide this proton inside the electron. Okay, so electron will be cloud. Electron is not like that circulating in a one circular path. We have studied previously. So electron is acting as a cloud around the proton. So this cloud will act as a shield towards the external magnetic field. So electron density is more means that cloud density is more. Electron density is more means cloud density is more, means more shielding will happen. Shield means what? If in a war, if you are seeing there is a shield, that shield will protect from the attack of the enemy, that is shield. We have seen human shield. Human shield, protesters will do human shield. So shield means it is protecting this proton from the external magnetic field. It can't protect that much, but it will protect somewhat. So how much it can protect, that much it will not experience magnetic field. For example, I am giving magnetic field unit is Tesla. Suppose I am giving 1 Tesla to this whole system. So the nucleus inside the electron, this electron cloud inside the nucleus, that nucleus will not get this 1 Tesla. Okay, why it will not get 1 Tesla? Because electron cloud will act as a shield for this, from this magnet, from this external magnet. So it will be somewhat less than the magnetic field we have applied. If we are applying 1 Tesla magnetic field, it may get some 0.999 Tesla. This nucleus will receive this much Tesla only, because this will act as a shield. So this is the background story. Now we will come for the answer. What was the question? What is the relation between electron density and radio frequency absorbed? Answer. First point. Electron has its own magnetic moment as proton. We have seen, we have already told in there, proton has magnetic moment. Electron also has magnetic moment like proton. If you apply external magnetic field, electronic magnetic moment will try to shield it. That's what I told. Electronic magnetic moment will try to shield. It will try only. It can't shield completely, but it will try to shield it. Which means that applied external magnetic field will different than the magnetic field experienced by the proton. That's what I told. 1 Tesla is applied magnetic field, but the magnetic field experienced by the proton is 0.99 Tesla. That's why I told. I will repeat it again. If we apply external magnetic field, electronic magnetic moment will try to shield it. Due to this shielding possibility of the electron, which means that the applied external magnetic field will be different than the magnetic field experienced by proton. Magnetic field experienced by proton. So simply we can say applied external magnetic field will be higher than the magnetic field experienced by the proton. Okay, if electron density around the nucleus is larger than, if electron density around the nucleus is larger, that's what I told. If electron density around, this is a hydrogen's case. If some other molecule has more than 1 electron or more than 20 electron or more than electron density is huge, then the shielding capability of that electrons also huge. That's what here written. If electron density around the nucleus is larger, then difference between the applied magnetic field and magnetic field experienced by the proton will be large. That difference means applied magnetic field will be huge, but magnetic field experienced by the proton will be less. So this difference will be large if we have more electrons. So electron density more means that difference will be large. If electron density around the nucleus is larger, then energy difference between the splitted spin state will be larger, will be less. Why energy difference between the splitted spin state will be less? I will explain.